Hi, welcome to this video. In my teaching, I have always been finding out that variable growth model valuation has been one of the most challenging part for a lot of students. So I want to use this video to show you a visualization approach and to use variable growth model to solve a valuation problem. Now let's start by looking at a question. The most recent annual, let's say 2023 dividend payment of LOL Industry, which is a rapidly growing EV battery manufacturer, was $1.50 per share. The firm's financial manager expects that these dividends will increase at a 10% annual rate, let's say that's G1, over the next 3 years. At the end of 3 years, which is the end of 2026, the firm's mature product line is expected to result in a slowing of the dividend growth rate to 5% per year, let's say that's G2, for the foreseeable future. The firm's required rate of return R is 15%. Then the question is, what is the value of the stock? Now to solve a question like this, I would suggest that you always start by plotting a timeline and make sure that you put all the information that you know on this line so that you know exactly what you are trying to solve for. In this case, you are trying to get the valuation for this stock, which is based on the valuation of the future cash flows that this stock will generate. So essentially, you are trying to get the present value of a sequence of a cash flow this stock is expected to generate in the future. Now, to get the valuation of that sequence of a stock, dividends, what I'm suggesting you to do is to break down the entire cash flow based upon the different growth rate that the question tells you about. So in this case, in the next 3 years, the dividend growth rate is going to be about 10% per year. So let's make that a green part of the cash flow. And following those 3 years, the subsequent year's dividend growth rate will be 5%. And let's make that as a blue part. Now note that for the green part, the cash flow only occurs for 3 times. And for the blue part, the cash flow is actually happening for an infinite amount of time. Okay, so in this case, to solve for the entire present value of the sequence of cash flow, what we are literally doing is to first figure out what is the present value for this green part, and then we're going to add the present value of the blue part. Okay, with these two parts adding up all together, we will get the present value of this entire cash flow. Now, in terms of calculating those two parts of the cash flows, let's start by working on this green part. Now, I want you guys to pause the video for a moment now and try to answer this question. Can we use the constant dividend growth model to estimate the value of the green part? Now, constant dividend growth model is a model that will help us to get the present value of a constantly growing sequence of a cash flow, in a sense that the cash flow will grow at a constant rate, and the cash flow will grow indefinitely, which means it will never stop. So based upon this, think about this. How about this green part? Can you use constant dividend growth model to estimate the value of it? Now, this is the answer. I hope you get it right. The answer is no. Now, in my teaching experience, most of the time, I would always get like more than half of the class getting this question wrong. Lots of students will just neglect one of the most important conditions for the constant dividend growth model to work. They will say yes, because they neglected the fact that this green part only lasts for 3 years instead of like a forever cash flow. With that, you simply cannot use constant dividend growth model to estimate the value for the green part, because this sequence of cash flow does not last forever. Now, how to get the value for the green part? Luckily, we do not have too many cash flows to worry about, so it will be quite easy for us just to calculate the cash flows 1 year by another. For example, since the question tells you that the dividend for 2023 has been $1.50 with a growth rate of 10%, you should easily get the dividend for the next year will be $1.50 multiplied by 1 plus 10%, which is $1.65. And then subsequently, you got a dividend for 2025, which is just 10% or more than the dividend for 2024, so on and so forth. So with that, we can easily get the sequence of cash flow generated by the stock during the years of 2024 through 2026. And then we can simply calculate the present value of those three cash flows. If you have a financial calculator, I believe you must have a CF function with it. So just punch in those numbers with the appropriate discount rate of 15%, the financial calculator should be able to tell you the present value of those three cash flows in total today is going to be $4.12. If you do not use a financial calculator, simply discount each one of those three cash flows at a discount rate of 15%. Okay? All right. Now let's solve for the present value for the blue part. Now notice that the sequence of the cash flow happening from 2027 and onward would be a cash flow that will last forever. It never stops and it grows at a constant rate of 5%. So in this case, we can simply use the constant dividend growth model to estimate what is the value for this blue part of the cash flow. Notice that if you use constant dividend growth model to estimate the value of a sequence of a cash flow, you must be sure to note that this model will tell you the value of that sequence of a cash flow at the time, which is one period preceding to the first cash flow of that sequence of cash flow. Okay, so in this case, since the blue part starts at the year 2027, so if you plug in the numbers into the constant dividend growth model, the model will tell you what is the value for that sequence of cash flow in the year of 2026. So with that, we can calculate that for the value of this blue part of the cash flow in year 2026, that is going to be year 2027's dividend divided by R minus G. So R here means the required rate of return of that cash flow, and G means the growth rate. Since the question tells you that the R here is 15% and growth rate is 5%, so we got our denominator solved. For the numerator, make sure that you multiply 1 plus 5% by the dividend of 2026, which we just solved for it a couple slides ago. So that was $2 for the dividend of 2026. You multiply that by 1.05, you get a $2.10 being the dividend for 2027. So you divide that by R minus G, and you should get the price, or say the value of that blue part in 2026 is actually $21. Now, $21 is not our final destination because eventually we want to know what is the value for that blue part today. So one last part here to calculate is that we need to discount this $21, which is the value for the blue part in 2026, back to today, which is 3 years before 2026. So in this case, we just need to do a regular time value of money operation where we make the future value of this operation as 21 because that is a one-time deal in 2026. Okay, so that's $21 being the future value. Number of period is 3 because from 23 to 26, they are 3 years apart. Discount rate is still 15%, which is specified by the question. And we want to compute what is the present value. So using a regular financial calculator, it doesn't take you too much time to get the present value of this question is $13.81. And $13.81 represents the value of this blue part cash flow today. Finally, we can simply add the value of green part, which we figured out was $4.12, add it to the value of the blue part today, which is $13.81. Putting them all together, you should get the value of this entire sequence of cash flow being $17.93. I hope this video helps. See you next time. Goodbye.